Today we will learn about current electricity. This is very important topic and important chapter for both academics as well as future studies like in intermediate and for engineering subjects also. This is a basement course and this is very important subject. So we will learn from very basics like element. We all know about elements. Yes. Every element in this universe, every element is composed of atoms. We have already discussed this in our previous classes. So every element in this universe is composed of some atoms. If you observe atom clearly, atom is again composed of a nucleus surrounded with electrons. See, a nucleus surrounded with electrons. This is electron. I took a negative charge here. Electron charge is negative. That is why I represented in this way. Electron. Okay, this electron revolves itself. See, this electron revolves itself and it will revolve around the nucleus. This nucleus is again composed of protons as well as neutrons. Yes, this nucleus composed of protons and neutrons. This is nucleus. Let me revise. Every element in this universe composed of atoms. If you take one atom, if you observe that atom carefully, again atom is subdivided into protons, neutrons and nucleus. Nucleus is the central part. In this central part you will have protons, neutrons. These protons will have positive charge. These electrons will have negative charge. Okay, these electrons will have negative charge. See, if you observe clearly, these electrons will revolve around its own axis as well as it revolves around the nucleus. It revolves around its nucleus. Now, depending upon number of electrons, my materials or elements, electrical materials are classified into conductors, semiconductors and insulators. Conductors, semiconductors and insulators. Conductors. In this conductor, the number of electrons are very large. If you have more number of electrons in an element, that element or that material is considered as conductors. So, number of electrons here are more or very large in number. For example, if number of electrons are very less in number, very less, very few, then those are called insulators. If the number of electrons are less than conductors but more than insulators, those type of elements are called semiconductors. These two you will understand or you will learn in your future classes. But our chapter is current electricity. That current electricity needs conductors. Why these conductors? Why we need these conductors? How these conductors will influence the voltage, current, and how our household elements like bulb, TV or whatever the electrical element is working with the help of conductors, we will observe in this topic. Thank you. As we already discussed that in conductors we have large number of electrons. So let me take one conductor. See, let me take one conductor. This is the piece of one conductor. In this conductor we have a very large number of electrons. See, these dots I am considering as electron. Yes. If we have this very large number of electrons. So if we have very large number of electrons in that material or element is called conductor. Now see, we have one conductor. These conductors are, in these conductors we have very large number of electrons. These are very close to each other, very close to each other. Now for example, if I give any force, if I apply any force to this conductor, see, now for example, if I apply any force here, if I apply force here, this electron, whatever the force it is getting, this electron will vibrate. First it will vibrate. Before giving any supply or before giving any voltage or before giving any force, this electron will revolve around nucleus in random manner like this. For example, this electron will move in this way, in this way. Randomly, it is revolve around randomly. Because of this randomness, what will happen? This charge and this charge. See, the orientation of this charge means direction of this charge is in this direction. This direction is in upwards. This direction is downwards. So that the net charge, this positive charge, see, this charge and this charge will cancel out. The net charge will become zero. That is why in normal conductors, without any supply, In normal conductors, without any supply, there are more number of electrons. Still, we cannot observe any current. Why? Because the net charge present in this conductor becomes 0. Now, what will happen if you supply, if you give some force? That force will directly enter into the conductor, and this conductor we have number of electrons. This electron will vibrate, and this vibrated electron will collide with neighboring electron. This electron will collide with neighboring electron. See, this electron will collide with neighboring electron. With these collisions, this electron collide with another electron. Now transfer of charge will take place. Transfer of charge. Yes, with this collision, charge is transferred to the very next electron. So transfer of charge is nothing but current. This transfer of charge is nothing but current. See, current. If you want, for example, in a conductor, if you are observing more current, that means transfer of charge is also more. That means collisions is also more. That means vibration is also more. That means force or supply is more. So here force is physics term, but for current electricity, force is treated as voltage. Force is treated as voltage. That means more current means more transfer of charge. More transfer of charge means more collisions. More collisions means more vibrations. More vibrations means more voltage. That means in a conductor, if you have more current, that means it is having more voltage. If you have less amount of current, that is it is having less voltage. That means in a conductor, current in this conductor is directly related to the voltage. Current in a conductor is directly related to this voltage. This is the relation of Ohm's law. This is the relation of Ohm's law. That means Ohm's law. What Ohm's is saying, in a current in a conductor is directly proportional to the applied voltage. How applied voltage is affecting? With this applied voltage, you will give some force to the electrons. With that force, electron will vibrate. And this vibration, because of this vibration, this electron will collide with very next electron, and because of that collisions, transfer of charge will take place. This transfer of charge or charge per time is nothing but current. The small I is current I. Q means charge per time. Rate of change of charge with respect to time, or we will call it as transfer of charge. This transfer of charge is nothing but current. So if you are having more current, that means you are having more voltage. If you are having less current, that is you are having less voltage. Current in a conductor is directly proportional to the applied voltage. This relation was given by the great scientist Ohm. With this Ohm's law, this is the fundamental in current electricity. With this Ohm's law, we will see different types of circuits. We will observe what is circuit, how circuit is going to be connected in series, how circuit will be in parallel, and everything we will see in our upcoming lectures.